let's start, guys. So before we move further, let's revise the things what we discussed till now. Correct? Lot of content was done. We were talking about SGA part and the background processes we recently started now. We got the data files here. Data files. What is the first data file name? System data file, correct? We got other more files here. Then we have redo logs and a control file. SGA is divided into multiple DB buffer cache, or let me simply write buffer cache, redo log buffer, shared pool, large pool, Java pool, and a streams pool. We discussed about the shared pool component. What we have, we got two things. One is library cache and a data dictionary cache or cache. So data dictionary cache contains the metadata. Metadata is loaded there, and also the statistics which are used in parsing and execution plan generation. And after the plans are generated, right, a cursor gets allocated here in your library cache in which your statement, parse code, execution plans are stored. Then, so they can be reused. The same statements, if we refire them again, the same execution plan will be reused. Now we discussed about the buffer cache or cache. We got two lists here. One is called as LRU list and the another is called as checkpoint queue. I'm writing it shortly. Checkpoint queue. LRU list and the checkpoint queue. Buffers, different statuses that also we discussed here, like a free buffers, used buffers, current buffers, and dirty buffers. Different states of our buffers. Server process, what it is doing, that also we understood. Correct? How your selects, how your DMLs get processed. We got set of tables or objects here. We call them as data dictionary based tables where you have your metadata and statistics, metadata and statistics. And this is another data file where we have all our users data in the form of tables and indexes. Is that correct? Right. Let me name these files. This file is a system.dbf and this one is users.dbf. We also discussed about one of the process. Who is this guy? Database writer, DB writer, and it gets invoked on certain cases. What are those? Invoked by server process when it is unable to find a free or used buffer while scanning the LRE list. After 4 attempts, it will invoke. The other thing, one more is what? There is some threshold limit. There is a threshold limit. Based on that, it also invoked. And there is one more. What is that? It is invoked by checkpoint process. What DB writer will do? Goes to checkpoint queue, takes all dirty buffer addresses from there and goes to each buffer here in the buffer cache and write them back to the disk. If any undo buffers are there, they are written back to the undo blocks here. We call these objects as undo objects. Let me have a separate data file named as undo.dbf. So undo data file will have undo objects in it. Users data file will have all my users objects, my tables indexes in it. Done. So this way, undo objects are used to store your before image, before value, right? How long it is going to store or maintain that information? How long it will maintain that information?
Once the transaction is committed.
Till you end the transaction by saying commit or roll back, by till that time your before image value is maintained in undo. Done. We also discussed about server process, all the three stages: parsing, execution plan, fetch. Correct? Yeah. So much of content we already gone through. The main components: shared pool, buffer cache. Please understand, these are the main two components. These are all optional, right? Not so important or mandatory, but these two are the main components in memory. Always keep it, right? Okay, let me move further now. Any questions before I proceed? Anyone? Any queries? Any doubts still you have? No? Good. Let me know. Move forward. So yesterday we discussed about a DML transaction like an update statement or something, what it may be done. So whenever you do any changes to database, right, by running a statement, select, when I run a select, is it going to do any change in database? Will it change any data? Nothing, right? You are simply just reading as it is. It's like a read only kind of content, right? But whenever you do a insert, update, delete, DMLs, using DMLs we change our data, correct? Not only that, even create, alter, drop, you are creating a new object or altering the object or dropping an object. So these commands, DDLs, DMLs, right, commit, rollback, these are all actually doing the changes in your database. Any change by any type of statements like that happening on database, the statement, what is this? This is a statement, right? Remember, this is the query. This is the SQL statement which is actually doing a change. Now this statement gets recorded here into this area. What is this area? Redo log buffer. Understood? Before I proceed, just give me a few seconds. Let me clean up this area because already we discussed this, right? I don't want these lines to distract us anymore, right? Yeah. So that. Now, whenever you do any changes by writing any, submitting any queries like this, update, insert, delete, selects are not recorded. Only the statements which are doing the changes in database, they get recorded into which a redo log buffer like this. So these entries are called as a redo entries. What these are? Redo entries. Your statements basically they get recorded or saved into the redo. Because of this update, right? What happened? Your table block was taken into memory, correct? And modified. Your data is here in the table which got modified, where it has loaded the data into your buffer cache. So data modifications happens in buffer cache. The statements which modified this data is recorded into where? Redo log buffer. Then, like this, any change happening in database, basically they get recorded into the redo log buffer. We call them redo entries. Now, redo log buffer is the smallest buffer among all the components, basically. Smallest. As I told, 10 GB is my SGA, 10 GB. Might be I'll give here 4 GB for shade pool, 5 GB for this. The remaining 1 GB might be 400 MB, 400 MB, 100 MB here. This is just couple of MBs only. Might be 5 MB, 10 MB, 50 MB, 100 MB, 200 MB, maximum like 400, 500 MB. That's really big. It is just in couple of MBs. Let's say example purpose, by default it is a 5 MB size, 5 or 8 MB something, 5 MB, yeah. By default, what is that? 5 MB size. So what happens? This 5 MB will be get filled up sooner and faster because of so many transactions coming in here? Yes or no? I am not only the one user, there are many users who are connected and everyone is doing lot of inserts, updates. Each and every statement is getting recorded here and that also recorded in the same order you are submitting, right? The first query, then second query, then third query, then fourth query, the same order, the way they got executed, it's recorded here into the Redolog buffer. Now, obviously, as the buffer is very small in size, it will be get filled up sooner and faster. As it gets filled up here, what happens? As it is filling up, this process comes in picture. Who is this guy? Log writer. Again, please, today's session is also same like that the previous one. Small bits. I'll be right talking about one concept for a few minutes. Again, I'll be moving on the other, and finally we'll make a complete explanation at the end. Right? Small bits. Don't get confused or distracted. So please be with me on the session. Right? Now, I was talking about, yeah, log writer. As it is getting filled up, this process comes in picture. Now, we'll come back to these two things again later. Wait, let me go back to my statement, right? So I find a update statement. Let's say this is that update statement recorded now. This is the update statement recorded. What happened? The block is taken from here. A block is taken from undo. Let's say here like this. The old value recorded here and the table value is modified to 2000. I hope it's visible. Correct? Yeah. Modified to 2000. Same yesterday's example. Done. Now what happened? This is the statement and the changes are done. Then server process will acknowledge the user process saying what? One row updated. One row updated. A row got updated here. Yeah, one row updated. Now what user did once I received an acknowledgement, I issued what? Commit. Now, when you say commit means what? You are saving your file. Normally, when you do your modification, we do a save. That time it will successfully write it and save it to your file. Correct? Same way here. When you say commit this transaction, commit the statement, right? There won't be any more further changes over it. It's over, done, right? Please commit it or save it. Now, what happens when you issue a commit actually? User says, I received an acknowledgement saying commit completed. Correct? Normally, when you type the command, commit, you will receive acknowledgement what? Commit completed, not the prompt, sorry. Commit completed. But what happening between the time? When you issue a commit, this guy is actually invoked. Who is this person? The process here, right? Log writer. Okay. So log writer is invoked on your commit. Now, what log writer will do? His job is simply go to the redo log buffer and take the redo entries and write it to the redo log file. One of the redos. I mentioned here two redo logs. Yeah, it is going to write it to one of the redo log. Understood? This is also like a sleeping guy. So whenever you issue a commit, the log writer is invoked. Log writer is going to go to the redo log buffer, take these entries. What these entries? Redo entries. So you mentioned after update, you mentioned commit. This is your update statement and also this is your commit. This is your commit. Both got flushed here. All your transaction, including your update and even the commit is written here. Once your transaction including commit got safely written to a file, this is a file on a hard disk. This is the memory area. Initially, when you fired your statement, it was there, it is there in your memory. It got now flushed and safely written to a file. Once log writer done, log writer will acknowledge it back. I am done. Then server process will acknowledge you saying what? Commit completed. You'll get a acknowledgement commit completed after log writer finishes flushing out all the changes in which your update statement and the commit record is available. Then simple. Now, what you will think, okay, example, I am the user and I am working there on my system. I updated and I issued a commit. I updated the salary and I said commit. Oracle acknowledged you, the server process acknowledged you, what? Commit completed. So I feel, okay, I'll say my transaction is now safe. I went to bank and I deposited some cash and I got an acknowledgement, right, from the bank person. Yes, your money is deposited. So I feel happy, safe now. Money is finally deposited into the account, right? After some time, the bank guy can't call me and ask me saying, yes, sir, ask me that, sorry, sir, the amount what you created, the transaction was not done. We lost that information. Is it accepted? No way. So it is ensuring, the bank is also ensuring giving a receipt. It is an acknowledgement. Now don't worry. Take this acknowledgement. Your transaction is successfully done. Same way, I got an commit completed statement here. It is Oracle. Oracle is actually assuring you that your transaction is safe with us now. Don't worry about it now. I'm happy. But what happened the next second after receiving this? Suddenly my server got crashed. Server crashed. Example, on my PC, not laptop. PC, if I remove the power plug, what happens? Suddenly off, crashed. It's not shutting down, simply crashed. Remove the power plug, suddenly crashed. Right? Same way like that, like power gone or some issue happened and suddenly server itself totally crashed. Everything is gone. Next time what we do, we check out the power plug and right, replace the power plug if it's a power issue, right, replace it and power on the server. Server came up, OS comes up, operating system. Then after that, I'll go to my Oracle and I have only database. So these are the files, correct? These are the files. This instance is gone. When your server crashes or instance crashes, your instance gone. Instance means memory, processes, everything is gone. Only the files are available for you in the storage. Next time when you try to start up your database, or before that, let me check in database, what is the value on my disk actually here now? On my disk, what is the value? 1000. Please remember the 1000 was taken here, modified to 2000. But is the 2000 value written back to the disk? No. What happened? Only the statement got recorded which modified it. Understood? So if I look at my database now after server startup, I see here the old value, not the new. So is your database consistent, up to date, or some changes are missing in it? Missing? The recent changes which we have done, which modified and kept in the buffer cache and also committed, but they are not yet written. Understood? So the database is considered here as inconsistent. What is that? Inconsistent. Now how this is done? Whenever you start up your instance after server boot up, when you start up your instance means memory and background process. When you start up, this process comes in picture. Who is this guy? SMON means what? System. Now SMON will go to each file and do a check. It will actually go to the control file here. No, what is this control file? Let me give the name control01.ctl. Right? So what SMON will do? It will go to the control file. What control file contains? What Redolog file contains? Redolog file contains all my redo entries flushed out from the Redolog buffer to the Redolog file. What my control file contain? This is the smallest file among all the three different types, right? Normally these files are in GBs, these files are in MBs kind of thing. And what will be the size of this Redolog file? Generally, thumb rule, right? It is somewhere around 10 times of the size of your Redolog buffer. If my Redolog buffer is 5 MB, I might give it as a 50 MB, 10 times to 20 times. 50 MB or 100 MB. If my Redolog buffer is 10 MB, it might be 100 MB, 200 MB, a little bit nearby. That kind of sizes. So this is in MBs only. But this control file is hardly 5 MB, 7 MB, 8 MB, 9 MB, 10 MB, 12 MB. Less than 10, less than 15 MB kind of size. Very small. What it contains lot of important information, right? Your structural information is there. What is that? How many data files I have totally, where they are located in which directory, what is the name of each data file, right? How many Redolog files I have, where they are located, what are their names, correct? Plus, what is the, when was the last update happened on this? When was the last update happened on this? On data file, there will be an update happening. Whenever it is writing, right? That information is also recorded. Hey, till this point it was done. So when your files got last updated, when your redo log files got last updated, all that information is there. Apart from that, your database name, your database mode, arclog mode or not, your backups information. When you're doing backups using a tool called as RMAN, we have a tool called RMAN. When you're doing a backups using RMAN, again, that time also all that information is stored in the control file. Lot of information. Fine. Now SMON comes in picture during the instance startup. SMON will go to the current control file. Based on the information, it will go and verify each and every file, and it will go and verify that they are all up to date or not. There it will find out that redo log file is having little more updates. Transactions are recorded here and seems like they are not yet written to my data files. So what happens here when it finds this difference, the way we understood here, right? Same way, when it finds the difference going through the control file, then SMON what it will do? It will go to the current redo log file and take all these transactions, right? And it is going to automatically execute them. What happens here when it is executing all the transaction? This transaction, your statement also loaded. So again, this 1000 block is taken, undo block was taken there, and modifications are done. So again, your table block is modified to what? Who is doing this one? SMON is doing. SMON is going to rerun all these statements from this redo log file. Done? So at the end of every statement, if there is a commit at the end of any transaction, those transactions are committed. Again, it is going to commit now, saying, yeah, it is done. Correct? If there are no commits, there might be some other users also submitted some statements, but there are no commits. Before they say commit, server crash. So there is no commit at the end of those transactions. Correct? Then those transactions get rolled back automatically. So simply SMON is going to rerun all the transactions from this redo log file, and if any committed transactions are there at the end, they get committed, and if there are no commits at the end, they get rolled back. So this way your database became now consistent, up to date, with all the committed transactions are given back to you again, and after that your database instance is allowing users to access. We call it as a database got opened. Now the database is open for users. Now when you go and query, it will show you what value now? 2000. So your data is given back or not? Your data, whatever the change here you did, you were worried because of suddenly crash happened the next second, but Oracle has taken care of it. How? SMON, by performing, right, rerunning all these transactions automatically. Correct? We call this concept as instance crash recovery. What is this? This is called as instance crash recovery. Yeah, instance crash recovery. Whenever your instance crashed, only the instance crashed or your server crashed, right? Because these processes are mandatory. If this process got terminated, crashed, terminated, automatically your whole instance get crashed. These are mandatory must. Okay, same like notepad.exe is there when you open a notepad. If I kill the notepad, what happens? Notepad.exe, if I kill that notepad.exe, your notepad file get automatically crashed. Same way here. So there could be a number of reasons, like process might be mandatory, process might be terminated, memory issue might be occurred for your instance, or server issue, right? N number of reasons. So if your instance crashes, no worries. Next time when you say startup, next time whenever you say startup, SMON will come in picture and it will go and check the inconsistency among the files, and it is going to rerun all the transactions or all the statements whatever required, correct? And in that, if any transactions are having commit, they get again committed, and if there are no commits, they get rolled back, and after that database is opened for users to access. Opened for users to access. This whole scenario taken care by whom? SMON system monitor when? During the instance startup, and the scenario is called as what? Instance crash recovery. Instance crash recovery. Understood? Right? Okay, I just gave you some points, but let me go a little bit in detail with lot of terminology here. Let me add the things slowly, one by one. Done? Right. SMON crash recovery, we understood. Now, back to this guy. Who is this? Log writer. Log writer job is what? Log writer job simply to take the redo entries from Redolog buffer and write it to the Redolog file. Now I see there are two Redolog files I have. Let me give the names for them. Let me say this one as redo 1a dot log or redo 01. Let me make it as redo 01 dot log. The another is redo 02 dot log. So numbering. I got two Redolog files available. Now, log writer is actually writing to only one of the Redolog file. When it is writing to this Redolog file, the status of this Redolog file will be in what mode? Current mode. It is in which mode? So currently, this Redolog file is in use by your log writer. Then every time whenever log writer invoked, it will take the redo entries and write it to the redo log file which is in current. Done? Okay. Now once this redo log file got filled up, because this is also with some size, it is a file. As I told, like this is, if this is a 5 MB, might be my file could be 50 MB or 100 MB or 200 MB could be some file. So it takes some time, couple of seconds or minutes basically. Yeah, once it got filled up, what happens then? Once it got filled up, immediately log writer starts writing to the next redo log file. Log writer immediately starts writing to the next. What it is writing here? Redo entries. Now, when it starts writing to this redo log file, the status of this redo log file is changed to what? Current. That becomes current now. Now, whichever the file the log writer is writing, consider that one as a current one. What about the previous one? This was earlier current, right? This was earlier current, but now this became current. So what happened here? Log writer started writing to the next one. We call this concept as a log switch. What we call it as a log switch. Log switch. A log switch occur, a switch. Log writer, whenever it starts writing to the next redo log file, we call that as a log switch occurred, and the new redo log file will become as a current, and the previous redo log file status will be changed from current to active. Current to it becomes active. So what do you mean by active? What is happening during the active stage? Whenever a log switch occurs, we got another process. What is this process name, guys?
Checkpoint.
Checkpoint. CKPT. Checkpoint process. Is that correct? Yeah. So checkpoint process. Let me write checkpoint process. Now, whenever checkpoint process. Okay, let me put it here. Right. checkpoint process is invoked by, what is that?
log switch.
Ah, log switch. Whenever a log switch occurred, checkpoint process is invoked. Understood? Okay. CKPT, CKPT. Whenever a log switch occurred, checkpoint process invoke. One of the reasons to invoke. Now, what checkpoint process will do? Whenever checkpoint process invoked, what it is going to do?
Data process that can involve.
Hmm. What my checkpoint process is doing? Tell me, please.
Uh, will update the header.
Whenever a log switch occurred, checkpoint invoke. Checkpoint process will perform two tasks, guys. Here. What are those? What are those two tasks? Checkpoint process one, it invokes.
Right.
What is that? DBWR. It invokes DBWR. Visible online, guys? Is it visible now? It invokes. You seen here, right? DB writer is invoked by. Yeah. So whenever a checkpoint invokes, first it will invoke DB writer. Now, what DB writer will do? Please tell me, guys. You. What DB writer will do whenever invoked?
We'll go to the queue list and flash all the dirty blocks to
Not LRU. Sorry.
quick checkpoint queue.
Checkpoint queue. It goes to checkpoint queue, take dirty buffer addresses, and then goes to all those dirty buffers and flushes them to the disk. Done. That is the job. So flushing out all the changes, that is the job. Makes sense. Now please understand here, there are few things, right? What blocks it is flushing out here? These are dirty blocks. What blocks these are? Changes. Now these blocks got modified because of these transactions. You see there are so many transactions happened in the previous Redolog file. This was the previous current one. Now it became what? Active. So because of these transactions, all these transactions, whatever changes were there in buffer cache or cache still, they are immediately everything is flushed. So now my file will contain what value here? Got it? It flushed your 2000 value to the disk. The transaction which was happened here. Yeah, that's what it is doing. Once the DB writer flushes all the changes to the disk, then what? Checkpoint process, what it will do? The second job. Second is what? It will update or it will generate a new checkpoint number. It generates a new checkpoint number. A number. What is this checkpoint? It's just a number, incremental number, guys. It's just an incremental number in the Oracle database. It's going on. It's an just incremental number, a checkpoint. A number is generated and that number is updated in each data file header. Header means what? Again, data file consists of blocks. Data file consists of blocks. So initial some set of blocks, some group of blocks are reserved as a header. Reserved as. So from each data file will have an header, guys. Even your Word file, document file, PDF file, whatever the files are there, few set of blocks initially they are reserved to keep its own information. Correct? Why? Because might be if I take out a JPEG image, a photo image, and save that extension as .mp4, will it play as a video? It won't detect, right? Header is playing an important role, right? Header will keep lot of internal metadata related to that file. So each data file, a header, it will update that new checkpoint number in this, and the same recorded in my where?
Okay.
Control file. Right? When was the last update? Because whenever DB writer flushes out the changes here, then checkpoint process, what it is doing, generating a new number that's saying till this point, right? The changes are flushed and recorded the same in where? In control file. See, if you're reading some book material, novels, people generally read, right? They'll keep a tag. Whenever they finish every day, if you have a habit of reading a book, after reading 3-4 pages, we'll keep a tag. When you're ending somewhere, we'll keep a tag and leave it. Next time when I open, I know that, okay, till this point I'm done and I have to continue further, right? A pointer kind of thing we are leaving there, right? Same thing here. So checkpoint indicates that till this point, right, your transactions are safely written, right? And the same also recorded here. This is the whenever a lock switch occurred, checkpoint process invoked. It invokes DB writer to flush all the changes. Changes happened because of all these transactions. All these changes are now flushed, and then a new checkpoint number generated and updated on each data file header and also in the control file. So let's say this is the checkpoint occurred time here, right? Understood, please? Means what? All these transactions data is now, whatever changes were there because of these transactions are now safely written to the file. Agree? Yes or no? This is the checkpoint occurred. Before this, whatever transactions are happened, all those transaction changes are safely there on your files now. Correct? Now just again, let me add one more story. Like after this checkpoint, if the server crashed, instance crashed. Next time when you bring up your server and instance, when instance starting up, who is coming in picture? SMON comes in picture, same story, right? What SMON will do, goes to the control file, checks how many files are there, where they are located, are they same or not, yes, and what is the last checkpoint happened on them. I am going to verify, yeah, they also have the same file as per the control file. Now it is going to check the redos, how many there are, 2, and what is the last update. So this is the last update happened example, right? This is the last update happened on my redo. So it will keep an information, right? So your checkpoint is here and the latest update happened here. That means after this checkpoint, if any transactions are done, right? Do you see here? There are few transactions are happened. What SMON will do? SMON will simply redo or rerun these transactions. Do you want SMON to run these transactions also? No, because this update statement which modifies 1000 to 2000 is already there. Already my block is with the 2000. Do you need these transactions anymore? No. So that means before checkpoint, this the checkpoint occurred, right? Before checkpoint, whatever transactions not required, I need only the transactions which are occurred after the checkpoint. After the checkpoint. After checkpoint, whatever transactions are there. Now, basically, after checkpoint, where they are in the current one, they are not here because checkpoint happened in the last, right? When a log switch occurred, correct? So, after this checkpoint, whatever transactions are done, basically, you will find them where? Current redo log file. So again, please, when your instance is getting started, SMON comes in picture, goes to control file, verifies all data files and their headers and the checkpoints with them, and also the redo checkpoints also verified. And as it finds there are few transactions are done after the last checkpoint, which is having an update on data file. After this checkpoint, do you have any updates? As there is some update happened on the redo, in which redo that will be basically in the current one. So SMON will go to the current redo log file and redo all these transactions, right? And if any commits are there at the end of any transactions, they get committed. And if there are no commits, only some transactions happen, there are no commits, they get rolled back. So this way again, your committed transactions are committed, data is given back to you, right? How SMON, control file, data file headers, checkpoint, right? Consistency check. And if any transactions done after these checkpoints, if any transactions are there, they will be mostly in the current one. If it finds any, yeah, then it is going to redo all those transactions. So going through the current redo log file, it is going to redo all those transactions. Shall I continue? Right? Slowly I'm adding up the things. I'm changing the story stage by stage, step by step. Done? Now, we understood the log writer. Log writer job is to flush out the things from where? Redo log buffer. So when it is flushing out the changes, whenever you issue a, so log writer is invoked on every commit. Not only commit, log writer is also invoked on every 1/3 full. If it got filled up by 1/3 of your redo log buffer, automatically log writer is invoked. Correct? Log writer is also invoked for every 3 seconds. Every 3 seconds log writer is invoked and it is trying to ensure that it is flushing out. So n number of cases your log writer is invoked on every commit, 1/3 full of redo log buffer, or every 3 seconds. When log writer invoked, it will go to the redo log buffer, take redo entries and write it to one of the redo log file. Whichever the redo log file it is writing, the redo log file, correct? The status will be what? Current for that. Understood, please? Is that correct? Yeah, it is writing to the current one. So once it got filled up, what happens? Immediately log writer starts writing to the next one. This will become the new current and the previous current is changed from current to active. Active. This concept is called as log switch. So whenever a log switch occurred, your checkpoint process is invoked. Checkpoint, what it will do? It invokes DB writer. DB writer is flushing out all these changes. The changes happened because of all these transactions. The changes are all flushed here to the disk, and then it is going to generate new checkpoint number, updating each data file header and the same recorded in the control file. Right? And log writer as it is writing here, but what about the previous transactions? Are they going to be wiped or cleaned? No, no, no. It is simply going to overwrite that content. What it is doing? Simply overwriting it. Why to waste time in cleaning up? Simply overwrite. Once this got filled up, what happens? A switch. But before that, okay, you understood here? Checkpoint is invoked when? So a log switch occurred, this became the current, this was changed from current to active. Now this redo log file will be in active mode for some time. How long? Till the checkpoint completes both the stages. Invoking DB writer, flushing out dirty buffer, then updating data file headers and control file. Once both are done, this file status is changed from active to inactive. Active to inactive. Inactive means now this redo log file is available for overwriting, right? Because now after some time, if this file got filled up, as this file status is in which mode now? Inactive. log switch can occur and it can be overwritten by new transactions. Got it? Because the previous transactions data is already flushed. It is flushed. Understood, please? Different statuses of our Redolog files, minimum 2 required for this purpose, checkpoint happening, and this part, right, mainly which is done by checkpoint process, invoking DB writer and generating a new checkpoint number. This is called as a checkpoint event. What is this called as? Checkpoint event. Checkpoint event occurred by your checkpoint process. During the checkpoint event, the status of that Redolog file will be in active mode. Once the event is done, it is changed to inactive. That means my log writer can switch and start writing here. When it is writing here, this will become as active. When it is in active mode, checkpoint will do the checkpoint event. Once checkpoint event is completed, both the task is completed, then it is changed from active to again what? Inactive. Change from active to inactive. Understood? Current, active, inactive, different status. Any questions, anyone? Right? Redo log files, log switch, statuses, log writer invoke, redo log buffer, redo entries, then log writer. Another is what? Checkpoint. Whenever checkpoint invoked, it will do a checkpoint event consist of these two steps, one after the other. So when checkpoint occurred, whenever a now, checkpoint is also invoked whenever you make your database shutdown. What you are doing? Whenever you make your database shutdown. I'll just write it here. Database shutdown. When you do a database shutdown, you're closing the instance. So then again checkpoint invoked. It invokes DB writer because till that time any changes are there, please flush out and then update each data file header, redo logs, control file updates are done, and then I am going to close or shut down the data. It's a graceful way of slowly shutting down stage by stage. So whenever you do a database shutdown, checkpoint is invoked. There is one more thing, right? What is that another one? Whenever you make your data files, these are data files, right? Your data files logically referred as table spaces. Logically they are referred as table space or data files. Whenever you make your table space data files, what is that? Offline or read only. Whenever you make your data file or table spaces offline, or I want to make this data file as a read only. It should not allow any write. But when I executed the command, already some user has taken the data and modified some blocks. Correct? So what happens when you make it read only, when you run this command, checkpoint invoked, it will flush out all the blocks related to that file and update the checkpoint here on the data file header. Then this file is made as read only. Correct? Because there might be already data in the memory. Flush out everything. Once done, I'm going to make it as a read only. So whenever you make your table space or data file offline or read only, again checkpoint in. Understood? So in these three steps, scenarios, are you going to do this data file offline read only every day? No, we won't do until there is some requirement, else we won't do, right? Then are you going to shut down database every day, every minute? No, database shutdown we won't do. My primary job is to make sure my database is running 24/7 round the clock, the whole week, a whole month, whatever the time you wanted. Database availability, that is my main primary job. I can't shut down, right? Okay, so we are not doing this task every day. This one also we are not doing the task. Then when the checkpoint is invoked in that case, only a log switch. Whenever a log switch occur, a checkpoint number generated here. Recorded, right? Checkpoint number. Whenever a log switch occurred, a checkpoint generated here. Right? Whenever a log switch, checkpoint, a new checkpoint number generated during this time. All these transactions checkpoint. Right? After finishing, when a switch occurred, all these transactions, one checkpoint. Whenever a log switch occurred, a checkpoint is happening at this moment. Understood? Yeah. Now, in this scenario, I'll add a new one more scenario or a story here. Let's say I'm working for a database. Let me take that database as one of the banks. Let's say example ICICI Bank, and I'm ICICI Bank DBA. Monday morning, peak time, 11 a.m. Right? That time suddenly database crashed. Right? Okay. In this, what happening? Say this is the current Redolog file. Which one? That means this is the previous checkpoint occurred here. A log switch occurred and this became the current, and these are the transactions which are happened till now. Done. So instance got crashed, DBA notified they are unable to access database. I came in picture, I found instance is down. Let me do what? Start up my instance. When I started up my instance, who is coming in picture now? SMON. It will go and verify the inconsistency. It found after this checkpoint there are few transactions that happened before the crash. What it will do? It is going to re-execute all these transactions. So who is executing that? SMON is going to re-execute. Then after re-executing all these transactions, now instance is opened for users. What happened here? Instance crash recovery done by SMON by re-executing the statements. Now, how big this file is here? The file actually takes nearly half an hour to fill every day. In the peak time, it takes 30 minutes to get filled up. Right? So, nearly 5 minutes of transactions are happened. How much? 5 minutes of transactions are happened after the checkpoint, 5 minutes of transaction, and instance got crashed. During the startup, SMON will go to this current Redolog file and re-execute all these transactions again. How much time it could take? Nearly, example, 5 minutes. Right? It is going to take nearly 5 minutes for what? Crash recovery, and database is opened and given. Done? Okay. So in my scenario, Monday morning, now what happened, right? The Redolog file is nearly filled, ready to switch, near to switch kind of thing. Nearly 20 minutes of transactions are already done, near to switch, and suddenly got crashed. I came in picture, I found database instance is down. I am going to say startup, SMON going to do the crash recovery. What it is doing? It is re-executing all this transaction. The more the number of transactions, it takes more time for recovery. Let's say nearly 20 minutes of transactions are there. That means how much recovery time? Nearly example. I just gave a startup. SMON is doing a recovery, but everyone is behind you. Akal, what happened? Akal, what happened? Why it is down? It's doing a recovery, sir. Okay, fine. How much time? 5 minutes, 5 minutes, 5 minutes. 20 minutes are over. Everyone is waiting. What happened? And finally, after 20 minutes, database is opened and given to the users working. But this 20 minutes plus extra some more time, it is a downtime or not? Obviously, management will call you next. Why Akal recovery? You're saying some recovery, fine, but why 20 minutes for recovery? Can't be done in 5 minutes or 2 minutes or 1 minute? But they don't know about database. They want just only the concept. Can't we do this recovery in 2 minutes? Why you are spending 20 minutes? And that too on Monday morning. Right? Because every second is valuable. Every transaction is valuable there for their businesses. They can't lose, right? Affect or impact the customers because of n number of scenarios. No, right? So simply they'll tell you, Akal, I don't know, you're saying some problem, fine. And instance need to do some recovery, let it do, fine. But don't do the recovery or don't it, right? Do the recovery more than or spend time more than 5 minutes. maximum recovery time we are giving you 5 minutes, right? Your recovery should complete in how much time maximum? 5 minutes. That means my checkpoint should be how far from the crash point? Maximum 5 minutes. Yes or no? Because from the checkpoint only, after checkpoint, all the transactions are executed and maximum time should be 5 minutes. But here you see, right? Understood the story? Because the checkpoint is occurring only when a lock switch happens. So I have one more parameter here now. What is that? Fast underscore start underscore MTTR underscore target. Fast start MTTR target. What is MTTR? Mean time to recover. What is that? Mean time to recover. What it is doing? Whenever I say any parameter, guys, right? Whenever I say any parameter, I forgot to mention some more files for you guys. In the physical structure, I mentioned data files. Then I mentioned Redologs and 3. There are few more files also we have in the physical structure. What are those? One is called as a parameter file. Which file? Parameter file. Right? The another one is a password file. Another is a password file. And one more file will be there, basically alert log file. Which file? Alert log. And there are few more other additional log and trace files are there. The n number of log and trace files are available. So these are additional files, these are optional, but these are what? Mandatory. These files are mandatory, 3 set of files. There are few more other types of files related to your database also there. One of them is important. What is that? Parameter file. Because whenever I say, wherever I say any parameter, because how much SGA should be, what is the size you want to give for SGA, how much your Redolog buffer size, buffer cache size, shade pool size, everything you will define where in your parameter file. There is only one file where you keep all your parameters, your complete database control, your instance control, most of the things done by the parameters, they are all defined in this parameter file. Agree? What is the parameter now we are talking? Fast start MTTR target. MTTR, mean time to recover. Mean time to recover. Okay. Now, if I set this parameter value to 5 minutes, how much? 5 minutes. It's not the same 5 minutes, that value will be different there, right? Just I mentioned for our understanding. Just if I say 5 minutes, that means every 5 minutes a checkpoint invoked. Every 5 minutes a checkpoint is invoked, right? Yeah. Every 5 minutes checkpoint occurred, a checkpoint event occurs here, and DB writer flushing out these changes every 5 minutes now. We are forcing the checkpoint to occur every 5 minutes. Else this is only the one case, log switch it is happening, but I can set it, I want my checkpoint to occur every 5 minutes like this. Now by doing this way, what happens if the instance got crashed? Maximum checkpoint time, how far it could be from the crash time? 5 minutes. So my recovery can be done in now how much maximum time? Maximum time 5 minutes. So your recovery is in your control or not? Right. So this way you can control your recovery, guys. The parameter fast start MTTR target, which actually invokes the checkpoint, and the checkpoint is a 1 point, right? Because the SMON will do the crash recovery from the last checkpoint, whichever the last checkpoint, this one example. After this checkpoint, if any transactions are done, it is going to simply execute only those transactions and recovery is done. Faster? Yeah. So we discussed here today so much of content again. We understood the redo log buffer, redo entries, log writer invoking when it is writing to the redo log file, the states, right? A log switch again, then checkpoint process, log switch, DB shutdown, table space data file offline read only are based on a parameter invoked. It invokes DB writer and updates each data file header with a new checkpoint and updates the same in the control file. We also understood the control file here. It contains lot of physical structural information and also database information in that, right? Okay, this is another type of file. We got few other files. We'll be talking about them later. One among them, I hope you understood, a parameter file. Correct? We also understood a transaction, a commit, how the commit, when you do a commit, what happening? The log return input. So many things we covered up here in this today's session. Any questions, anyone now?